Okay, guys, so what we're going to do now is look at two-way tables and Venn diagrams, but looking at what we call conditional probability. So I'll explain what I mean as I go through. So first one, we've got a Venn diagram representing a certain number of people, so 40 people surveyed about their favourite sports. We can see those who like football and tennis, those who like tennis, those who like tennis and rugby, and all three. Okay, and 4 of them liked none of the 3 sports. Okay, so you would usually get worded questions in this case, but we need to know which relevant part of the Venn diagram we're going to. So find the probability of a student liking tennis and rugby. So in terms of your Venn diagram, tennis and rugby is where tennis and rugby overlap. So where do they overlap? Tennis and rugby. Well, this 6 here is in both tennis and rugby. This 3 here is also in tennis and rugby. So in total, 9 out of the 40 people like tennis and rugby. Probability 9 out of 40. If it was just asking how many people, it would be 9. Okay, next one, probability that a student liking tennis or rugby. Well, when we say or, we need to total up, consider both. So the total of your rugby circle and including the ones with tennis. Okay, so instead of just the 9, I've now got 2, add 4, add 6, add 3, add 15, add 5. Okay, and that should add up to 35 out of 40. Okay, so 2, 5, 10, 20, 35. Good, yeah. Now, this is where it gets tricky and what I need you to focus on, given that a student likes tennis. So what we are now saying is we know this student likes tennis. So what our fraction is out of has changed. How many people in total like tennis? Well, 4, 5, 6, 12, 13, 14, 15. So out of the 15 people that like tennis, we're now looking at, because we know, given that a student likes tennis, what is the probability they like football? So how many people in this tennis circle also like football? Well, we know that's 2, add the 3, which is 5. Okay, and hopefully that makes sense. So whatever the given that part is what we're considering it's out of, so out of tennis. And what the probability is, well, the total that like football that are already in this circle are 5. Okay, next one, given that a student likes tennis, so out of 15 again, what is the probability that they like rugby? Well, they're in the tennis circle, we know that. Well, how many of those people like rugby? Well, 6 add 3 is 9. Okay, so 9 of the 15 people that like tennis also like rugby. Okay, hopefully that given that part makes sense. It just alters what you're considering. Okay, pause the video and see if you can replicate that with this question. Okay, you should have given that a go. The first question, find the probability of a student liking tennis and rugby, so both of them. So it should be in the tennis circle and the rugby circle, so that's the intersection. 5 and 4 is 9, and it's still out of 40 because we're considering everyone. Okay, next one. Probability of a student liking tennis or rugby, so that's the total of the 2 circles. So that is going to be 33 out of 40. If we add them up, 7, 11, 16, 17, 18, 19, 20, 33, correct? Now, given that a student likes tennis, what is the probability they like football? Well, how many like tennis? 5, 10, 14, 15, 16. Of those that like football is 7. 7 also like football. And again, of those that like tennis out of 16, the likes rugby 2 is 4 out of 5, which is 9.